All right, here's a video for you to check your answers on the practice page in your packet. First, we have another ladder similar to the first one in your notes. In this one, it says the ladder is 20 foot tall. It's placed 5 feet off the wall. We want to know how high it reaches up the wall. So if this is our right angle, then h here is a leg. So we're doing 5 squared plus b squared, or you could put an h equals 20 squared. B squared equals 375. And last step, square root, and we get about 19.4, we'll say 19.4 feet. Okay, you might have rounded a little bit differently. That's okay. The next one, find the area. That's kind of a key here. Area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. So first I'm just going to draw a rectangle. So this represents our rug. It says it's 12 feet wide, and then the diagonal is 20 feet. Well, ultimately, we want to find the area of this, and in order to find area, we have to do length times width. Well, we already know the width is 12, but we don't know what the length is. The length is right here. And we don't know the length of that yet, or the size of that, right? So that's why we have to use Pythagorean theorem here. We're going to find the length of the rug, which happens to be a leg of this right triangle. So we're going to do 12 squared plus b squared equals 20 squared. That's 144 plus b squared equals 400. Subtract these. B squared equals 256. And then square root, we get b equals 16. So the length here is 16 feet. We still have to figure out the area, so we're going to go back up to the area formula here. That's length times width. Well, we just found that the length is 16 and the width is 12, so we're going to do 16 times 12, and that's 192 square feet. That's the label for area in this case, square feet. A baseball infield is a square, each side measuring 90 feet. To the nearest foot, what's the distance from home plate to second base? So first, it says each side of the square is 90 feet. And then we want to know the distance from home to second. So we want to know this diagonal. We can draw in a right angle there, and then hopefully we see we've made a right triangle. So we've got legs 90 and 90 equals c squared. This is c, that distance that we're trying to find. So we're going to do 90 squared, and that's 8,100, and there's two of them, so I'm just going to double it. So that's 16,200 equals c squared. Then I'm square rooting both sides, and I get about 127.3 equals c. And again, that's feet. So 127.3 feet. Last one, a giant California redwood tree cracked in a violent storm and fell as if hinged as shown. The tip of the once beautiful tree hit the ground 25 meters from the base. The still standing part of the trunk is now 10 meters tall. How tall was the tree before it fell? So in this diagram, before we eventually answer that question, if you see the triangle here, the part of the triangle we don't know is the kind of the cracked part of the tree that's lying down there. So this is going to be our hypotenuse, and we're going to do 10 squared plus 24 squared equals c squared. This would be 100. 24 squared is 576. Add those together, we get 676. And then the square root of 676 is 26. But we haven't finished answering the question yet, because the original question was how tall was the tree before it fell? Keyword before. We just found that this part is 26. But originally the tree, if you kind of like hinge that back up, we're looking at this part plus that part. So we have 10 meters. Oh, this is meters. I messed up that label earlier. So this is 10 meters and 26 meters for a total of 36 meters. That's how tall it was to begin with. Okay? If you still have any questions after watching that, if something's wrong on your sheet and you're not sure why, email me, let me know, and we can work on it together.